Welcome. I'm Mr. Harn, and I want to discuss a little bit about acceleration, which is our next step after velocity. So the way I like to think about things in physics is we have this object and it's sitting here. Okay, what does that object do? It's at rest. Now at some point that object's going to move, so it's going to change position. Where it was originally at xi, position 1, now it's sometime later, right? Sometime later, it is at x of f. So we know it has had a change in displacement. Excuse me. It's had a change in displacement or a change in x. There's been some distance traveled. And because time is changing, as our displacement is occurring, we have what we call velocity. Okay? So we start off with our basic system here, and we start off with an object that is moving the same distance in the same amount of time. So if we use these dots to represent our motion, we can see that the distance between each dot is approximately the same every time. So what does that mean? If you're traveling the same distance in the same amount of time, then you have the same velocity. So we think about this. Do objects always travel the same distance in the same amount of time? So each dot represents 1 second of time. Well, most objects will do this. Start moving slowly. And then the next interval, they move a little more, move a little further, move a little further. So if we record this with a dot timer, what we're going to see is that as the dots are placed, so as our object is moving, each dot represents its new position in the same amount of time. So if we add this, this is 1 second. This is 1 second later, 1 second later, 1 second later. So a total of 4 seconds. But what we see is during the first second, it went this far. During the second, and the third second. So what is the object doing? The distance the object is traveling in the same time interval is increasing. So that means the velocity is now changing. So if the distance an object travels increases in the same time interval that it had before, that means that the velocity is increasing. So for example, let's say this moves 5 in 1 second. So maybe it's 5 meters per second. And so this line's a little longer, we'll call it 7. So this object is moving 7 meters per second. This one's a little longer, we'll call it 9. So this is moving 9 meters per second. This one's even longer, we'll call it 11 meters per second. So now we can ask ourselves, at what rate is the velocity changing? So we know our velocity is a change in distance, change in displacement over time. And we know if we change the same distance every single time you change the same distance, you have constant velocity. But if the distance you travel gets greater and greater and greater, in other words, in 1 second you're traveling a greater distance than you did before, you are changing your velocity. So the question we come to now is, at what rate is the velocity changing? Okay? At what rate is the velocity changing? And that is called acceleration. So velocity changing at what rate? That is acceleration. Okay? Now, just look at these numbers right here that we've used. At what rate is this increasing? So it was going 5 meters per second. Now it's going 7 meters per second. So it increased by how much? It increased by 2 meters per second. And it took how much time to do that? Another second. So a good way to write acceleration units are meters per second per second. So we were at 7. We're now at 9. How much did it increase? It increased by 2 meters per second, and it took how much time to do it? A second. So a 2 meter per second per second. We were at 9. We're now at 11. 2 meters per second per second. So what is our our acceleration. At what rate is the object increasing its velocity? It is increasing its velocity at a rate of 2 meters per second. We would actually write that as a square. So a good way to think about acceleration is to remember that it's a meter per second per second. So if we say velocity, velocity is how much distance per time plus the direction, but we're just looking at the number. How much distance per time? Acceleration. How much faster or how much more velocity per time. Okay? So let's look at two numbers right here in this, and we'll kind of bring this to a final. So if you say you have a velocity of 5 meters per second, that means you go how much distance? 5 meters in how much time? 1 second. So you go 5 meters every second. Every 1 second. So if you traveled for 2 seconds, 5 the first second, 5 the second, a total of 10. Let's do that same idea with acceleration. Let's say you have an acceleration of 5 meters per second squared. Okay, a good way to read that is to rewrite that as 5 meters per second per second. So what it means is how much faster or how much change in velocity per time. So let's say we started out at 0 meters per second. Our car is at rest. Now what's our car going to do? It has an acceleration of 5 meters per second squared. So 1 second later, the car will now be going 5 meters per second. All right, how fast will it be going after the second second? So 1 second later, it's going what? Well, it's got an acceleration of 5. That means it gets 5 meters per second faster every second. Was at 0, it's now at 5, it's now going to be at 10. And if I were to continue this acceleration, I would now move to 15 meters per second. Okay? So if we back up for just a moment, if an object has an initial position, sometime later it has a new position. Because time is traveling, it has a change in distance or displacement over time. That's called velocity. We would see that as dots that are equal distance apart. And each dot represents 1 second in time. Now let's say that an object travels 5 meters, then 7 meters, then 9 meters. It gets a greater and greater distance. That means the velocity must be changing. And we can ask ourselves, at what rate does it change? That is acceleration. So the dots that get further apart means that the car is accelerating, means it's getting faster. And it means that there is a rate at which it's getting faster. So if I was at 5 and I'm now 7, I got faster by 2. 9 was 7, 2, 2, and then finally an acceleration of 2 meters per second squared. A good way to read that or to think about that is take that meter per second squared and write it as a meter per second per second. So you're getting 5 meters per second faster every second. Okay?